Yeah, Infinite Canvas will tell you what your grade is.
Yeah, I'll check.
All right. Okay, so last time we talked about the mole in broad terms. We talked about it being a ratio between things we can weigh, grams, and things we cannot weigh, atoms. And we talked about the molar mass. And we look on the periodic table and we can find the molar mass on the periodic table. We calculated the average atomic mass, which becomes the molar mass. Why do we have to use average atomic mass and not just the atomic mass?
Because there are a lot of isotopes.
Excellent. Yeah, there's a lot of isotopes. So when you dig up some iron, you don't just get iron 56, you get 57, 58, 55. So we use an average, which is a weighted average, called the average atomic mass, and that becomes the molar mass. And we talked briefly about what the mole was. The mole is a number. Who remembers what the number is?
6.022 grams per mole.
Yeah, exactly. It's 6 times 10 to the 23rd things per mole. This needs to be updated. We're at about 7.4 right now. So the mole is a huge number. It's 6 with a giant pile of zeros after it. If that's thousands and that's millions and that's billions, that's trillions, it's 1,000 billion trillion, almost. About 0.6 billion. It's huge. So 6 times 10 to the 23rd things per mole. Now the things are usually atoms, but they don't have to be, but they're usually atoms. So we're calling this Avogadro's number. Talked about it yesterday. And if you want to determine how many atoms you have in a certain number of moles, you do just like if you had dozens. If I said, I need 3 dozen donuts, then you just multiply 12 by 3. Well, if you need 3 moles, you just multiply 3 by 6 times 10 to the 23rd. Okay? If you needed half a dozen, you'd multiply 0.5 by 12. If you need half a mole, you'd multiply 0.5 by 6 times 10 to the 23rd. If you needed 2 dozen, you'd multiply 2 by 24. And if you needed 2 moles, you'd multiply 2 by 6.0 times 10 to the 23rd. So I'm not telling you anything that you didn't hear yesterday. Just want to make sure we start on a good note today. Okay. Any questions about molar mass or the mole or anything like that before we jump into conversions, which is the meat and potatoes of molar mass, the unit we're in right now? Okay. Everybody got your calculator warmed up? Okay. Everybody got your note-taking finger ready to go? Okay, let's jump right in. So, molar mass is once again the grams of something per mole, and we find it on the periodic table. It is molar mass and it's grams per mole, and we find it on the periodic table. What this means, practically, is if I ask you to go into the back and measure out 1 mole of nickel, you're going to come back with 58.7 grams of nickel, or 58.693 if you happen to have a balance that goes out that far. Okay. Because this is the molar mass of nickel. It is the number of grams in 1 mole of that thing. And if I said I could really use some tellurium, how much do you want? 1 mole. You're going to come back with 127.6 grams of tellurium. Get the general idea? Yep, they're all different. They're not round numbers because of the atomic mass. And I said, you know what? I went to Amazon and I needed to buy some iodine. How much did you buy? 1 mole. Oh, great. They had it at a 126.9 gram container? Yeah, that was 1 mole. 126.9 gram. Amazon has everything. Okay, so that's how it works. And over here I have containers. So in this container I have 1 mole of sugar. Turns out to be 342 grams of sucrose. In this container I have 1 mole of sodium chloride, table salt. Turns out to be 58.4 grams of table salt. In this container I have 1 mole of silicon, 28.1 grams of silicon. In there is 28.1 grams of silicon. And I know it was going to be 1 mole because I looked on the periodic table. It said 28.1 grams. I weighed out 28.1 grams and put them in the container. Okay. And then here, we got some tin. 118.71 grams of tin in here. And I know it's 1 mole because tin is 118.71 grams. Okay, is this starting to make sense? Yeah. You're like, so that's what that number is about. Yeah, it's an actual really, really handy tool, something we actually use to determine how much we need. So if I need, and this is what's going to happen to you in December, I need 0.2 moles of this chemical. Well, I can't weigh out moles. I can't weigh out atoms. But what I can weigh out is grams. So you take your moles and your molar mass and you rub them together and you'll know, oh, I need that many grams. Okay, and then you just go out and powder in the container and into the container. Okay. So, and that's what we're doing today. We're going to be converting between grams and moles. Okay, so really quickly, we're just going to make sure we all know how to do, actually not really quickly, we're going to take our time. We're going to make sure we all know what molar mass means. Okay. So the average atomic mass of carbon is 12 grams.
Mr. Ruth is offering cookies to all the teachers. Would you like 2?
2? I can have 2? Oh, thank you. I'll have the 2 biggest. Cookies! I got cookies. I'm going to eat them after lunch. Do not envy. It's a sin. No, just the 2 now. Okay, so the average atomic mass is 12 grams of carbon. What is the mass of a mole of carbon? You blurt it out.
12.101.
Yeah, it's 12. That's what that means. If the average atomic mass of carbon is 12, that means a mass of carbon weighs 12 grams. What is the molar mass of copper? This is where you get to use your periodic table. First exercise of mini. Yeah, about 63.5-ish.
Yes.
Okay, so yeah, you just look at the periodic table. There it is. Boom. And what that means is, if I need 1 mole of copper, I'm going to weigh out 63.5 grams, which is what I did over there. I wanted a container with 1 mole of copper, so I got some copper and I weighed out 63.5 grams, put it in the container, sealed it off, boom, 1 mole right there. Yeah, pretty simple stuff. Now, there is one thing I do need to mention, rounding. Some of you are the kind of person that likes to have as many digits as possible. I don't know what your deal is, but you like to have as many digits as possible. You like banging things into the calculators, and you need to have a whole bunch of digits, and you're going to I'm going to use 63.54612 multiplied by, some of us are just going to round. We're going to 63.5, good enough. So whether you round early or round late, whether you use 2 digits or 5, that's okay. Okay? In a multiple choice exercise, you're always going to have, you're going to have 2 numbers, you're not going to have 2 numbers that are close together. The options would be like 31, 64, 18, and 12. Okay? They're not going to be like 39.1, 39.15. You're not going to see that. And on open-ended exercises, if you're in the neighborhood, if you're within 1 or 2 of what I have, we're good. Okay? So don't worry about weird rounding issues. As a general rule, I like 3. 3 is my favorite, 3 digits. But you can use more or less. Don't use 1 though. You can use 2, 3, 4, 5. Okay, so yeah, copper is 63.5 grams per mole. Next, what is the molar mass of nitrogen? 14.007? 14? No. Because if you would have been paying attention, after nitrogen I wrote N2. Why did I write N2 and not just N?
So it's 28.
Exactly. Nitrogen is one of those crazy diatomics that's never by itself. So the nitrogen you're breathing right now, as about 78% of the air you're currently breathing, is N2. Remember Brinkelhoff? So if you don't remember the diatomics, you remember here, we have a fancy little mnemonic. It's Brinkelhoff. and nitrogen is the N in the Brinkelhoff. So it's diatomic. It's got to be N2. Okay. So if you saw just N, it'd be like N in something, then it would be 14. But nitrogen gas is N2, it's 28. So all we did was multiply the 14 by 2. Now in chemistry, numbers behind something refer to the thing right before it. Okay. In algebra, they just put numbers in front. We put numbers in front too, but they mean something different. In chemistry, it's a number right after it that says N2 means you have two N's. All right. If that concept makes sense, give me a thumbs up. Make sure you're still awake. Cool. All right, moving on. What is the molar mass of CO2? This one's going to take you a little bit longer. Please do not blurt it out. When you have the molar mass of CO2, please show it to a neighbor and compare your answers, and then we'll come back together in a couple minutes.
What did you get? CO2. God damn it, I need cobalt.
Yeah, remember, cobalt is big C, little o.
Okay.
Hey, it's okay. It's okay to be wrong now. Just don't be wrong on the test. If you got a number that is similar to your neighbor's, give me a thumbs up. Okay, looks good. All right. If you got a number larger than 10, raise your hand. Looks good. Larger than 20. Larger than 30. Larger than 40. Larger than 50. Ah, good. So yeah, you got about 44? Yeah. So for those who are like, I didn't get 44, I got 55 million. You got one carbon and two oxygens. Carbon gets you 12, the oxygen gets you 16 and 16. Then you just add them together. Dan?
So you only add, you don't multiply?
You can multiply the 16 by 2. But you add the 12 to the 16 and by 2. Yeah, don't multiply them together. It's kind of like if you were, it's like your ingredients. Your molar mass is your ingredients. You need 1 scoop of this and 2 scoops of this. Are we cool? Moving on. Okay, now we're just going to do practice for the rest of the day. Okay, so we're just going to walk through practice for the rest of the day, and I got to show you. Actually, yeah, not right now. Okay, we're not going to take a lot of time on molar mass because I want to spend more time on conversions. But we do want to make sure we know what we're doing because we're going to need the molar mass when we're doing our conversions. So find calcium on your periodic table and show it to your neighbor. So if I asked you to get me a mole of calcium, how many grams are you coming back with? Yeah, about 40? Yeah, 40 grams of calcium. What about chlorine? Again, chlorine is the coal in the Brinkelhoff. This is chlorine. Yeah, I know it can be weird, but yeah. You'll learn in a little bit that Ci2 would be very, very unstable, and you wouldn't see it in this class. You might see Ci4, but not Ci2. If I walked in with a big glass bubble, and in that glass bubble was some yellow gas, and you said, "What's in the bubble, Mr. Byers?" And I said, "Chlorine." And you said, "How much?" And I said, 1 mole. You would say, "Oh, you have 71 grams." Good. Remember, chlorine is diatomic. It is the coal of the Brinkelhoff. So you take your 35.2 and multiply it by 2, and that bubble of chlorine, which would actually be 22 point, be about this big, would weigh 71 grams. Bubble, about this big. Question? I'm sorry, guys, I can't hear the question. Diatomic.
It's one of the Brinkelhoff, that means that if there's 2 of it, it equals 1 something.
Yeah, it's going to be written down. It's going to say Cl2, and the reason we need to practice this is because eventually it will be up to you to determine when it's just Cl and when it should be Cl2, when something should be O and when something should be O2. But right now, since it's Cl2, diatomic, double your chlorine.
But what I'm confused about is like, I got 1 mole, but then it's not 2 moles, it counts as 1 mole.
Right. It is 1 mole of Cl2. So it's 1 mole of things that come together in a pair. So it is technically 2 moles of chlorine atoms, but it's 1 mole of Cl2. It's 1 mole of the formula written. Is that clear? Excellent. So thanks for bringing that up. All right, and now if you slap them together, what should your mass be if you have 1 chlorine or 1 calcium and 2 chlorines?
111 grams per mole.
111 grams per mole. Okay. Okay. Give me a thumbs up if you're good so far. All right, now we're going to start adding small chunks of complexity. We're going to use water a lot. Water is H2O, and the 2 finds itself between the hydrogen and the oxygen. To what does it refer? Hydrogen. The hydrogen. Good. It refers only to the hydrogen.
When does it get like extra?
Really never. It's just applying the rules. It gets bigger, but it's just applying the same rules. Yes?
Is the reason helium floats because, or like rises because it's lighter than the nitrogen in the air?
It's lighter than the air, yes. Yeah. Helium is less dense. For the same volume, helium has fewer molecules, less mass, making it less dense. So, yeah, less dense, up it goes. And then you take physics, you find out how fast it goes. It's like not only does it rise faster than air, it rises this fast. Yeah. Okay, now here's something new, parentheses. Parentheses work just like they do in algebra. They refer to everything inside. So this chemical is called barium hydroxide, and barium hydroxide has in its formula 1 barium and then 2 OHs. So there's 1 barium and it's connected to 2 OHs. So again, the 2 refers to everything that's before it, in this case, 2 OHs. I would, yeah. I do an oxygen plus a hydrogen and multiply it by 2.
No, like the barium.
No, you would not multiply the barium, because it's still just 1 barium and then 2 OHs. So you're still adding things up. It's like you're weighing Legos. So you got 1 big Lego and then 2 Legos stuck together, 2 of those 2 Legos stuck together. I think I just thought of a lab. Ooh. I'm going to write a Lego lab. I'm sorry? Ninjago? I haven't seen it yet.
The only reason I know about it is because people were always at Darwin's and I was in it.
Yeah, Legos are hardcore into the toys. The movies are just there to sell toys. Okay, barium is really, really big. Anyone need more time? All right. If you got a number larger than 100, give me a thumbs up. Excellent. Larger than 150. Excellent. Larger than 200. Okay, great. So I got 171? Okay. And again, if you got 170 or 172, totally fine. Okay. Moving on. This is iron sulfate. When you got your answer, lean over to your neighbor and see if he or she agrees with you. Iron's in the middle, top middle, and then sulfur's right below oxygen.
There it is. Okay, thank you.
Good tactic. Do it yourself. Don't trust your neighbor. If there's one life lesson I can teach you is don't trust your neighbor's answers. All right. Anyone need more time?
Yes.
All right. Take another half minute. I'll just be playing with my Angry Bird. All right, if you got a number larger than 100, raise your hand. Larger than 150. Larger than 200. 152? All right. Okay, now, the next one that comes up is pretty much the most complicated thing we do. This is like the top end of the complication we do. And now we have a whole bunch of parentheses and a whole bunch of numbers. Before you start banging your calculator, how many aluminums do you see? 2. How many SO4s do you see?
No, it's 1.
There are 3 SO4s. So you can approach this multiple ways. You can say, well, I have 3 sulfurs and I have 12 oxygens. Or you can say, I have 3 SO4s. Okay? It's commutative. So go ahead and figure this one out. It's a big molecule. It's very heavy. You will, again, when you figure it out, show your neighbor, compare your answer to your neighbor's.
I said.
Looks like